have something really awesome to talk about today. It's, well, I can't really say that. I gotta give another minute before I start. But, yeah, it's pretty freaking awesome. So, once I see either the clock change one more minute, or if I see one person jump on, I'll be starting this off. But, yeah, pretty stoked for today. One more minute. We got a tripod for the iPhone, and doesn't work. It's supposed to have a microphone on it, and it sucks pretty bad. So I've got my phone balanced up on the charger cable and a piece of concrete, and if I shake the table too much while I'm talking, it kind of falls over. So, all right. Good morning, ladies and gentlemen. My name is Dr. John Belkowitz. I am the Director of Research and Development at Intelligent Concrete, where we specialize in concrete research, development, education, and litigation work. Today I wanted to chat about IOT and concrete. And if you don't already know, IoT stands for the Internet of Things. And the concept is that we connect physical things to the internet that allows us to draw data from those physical things and make real-time decisions and have an impact in our life. And extending that to concrete over the last 5 to 10 years, we've been incorporating into our concrete construction sites these wireless or cloud-based sensors, whether it's in the ready-mix truck or it's in the concrete element itself, or the grout or the mortar, whatever it is. These sensors in these different environments for the construction and concrete industry, and those sensors relay information back to either the folks who are producing the concrete, engineers or architects, or the end user. So question is, why do we care? One of the places this has been done is maturity with concrete. And the concept behind maturity is, if you have a certain mix design, it's going to reach a certain maturity or certain age, which is normally identified by a factor that is a combination of the strength and the time that it takes to reach said strength. And what we normally do with that is we identify the maturity of a certain concrete mix in a standard environment, in a lab environment, and then we use those same sensors and activation energy with the mix that's going out to the field. We place sensors into the formwork, and what that does is it tells us the maturity of that concrete mix as it sits out in the job site. And the way maturity can change is if the concrete is hot, if it's a hot day out, if it's hot formwork, if it's a hot concrete, and it's a little bit hotter than was in the lab, that concrete time, that concrete maturity, that concrete strength and maturity will set up a little bit faster, or a lot of bit faster, meaning you'll get to your strength sooner. The opposite is, if it's colder than it was in that standard environment, it might take more time for you to reach a certain designated strength. And the reason why that's important, let's say you're on a job site, you're working on some decking, and you want to pull some formwork to move on to the next floor. Pulling formwork too soon could jeopardize construction workers' lives. Pulling formwork too quickly or not fast enough can mean that you're wasting time and money. Ergo, the idea is to use a maturity sensor, which is normally a temperature logger, that then converts that temperature and time into a maturity value, and that value can be plotted versus the strength to give you an early warning sign, or I guess a better way of saying it is real-time data to make a decision about when to pull the formwork and replace it, or to get traffic on your concrete slab sooner. Again, this is just one explanation or one example of this IoT where we're using a wireless or cloud-based temperature sensor with an algorithm to tell us when that concrete has reached a certain strength. Because the old method of doing it, and I guess that's something I didn't talk about, the old method of doing that is using concrete cylinders, where we would cast some concrete cylinders, leave them by the slab, and from there we would break them at certain intervals. But even that, it's definitely a more conservative method, and you're not saving as much money, and you're really not making a real-time decision. You've got that delay of taking the samples from the job site to the lab, and then breaking them in the machine, to make those decisions. So anyway, I hope you enjoyed the spiel, the concrete talk on IoT. We've got a few articles coming out on it that we'll be posting here in the next couple weeks. We're pretty excited to go after this. We've got a lot of folks who are working with some great technologies for concrete ripping and stripping of forms, sensing movement of concrete, energy identification. So it's definitely an interesting topic, and I hope you enjoy the articles that we write, and we'll be doing some more videos on this as well. So anyway, have an awesome day. Thanks for your time. Go concrete. Beat asphalt.